Hello and welcome to our lesson on the law of sines for our trigonometry class. This is from section 8.2 in our textbook. And I guess to start with, notice here in the red box, I have the formula for the law of sines. It is only one line of code. And if I could illustrate kind of what it says here, it says if you take the sine of A and divide it by side A, that will be the same ratio as if you take the sine of B divided by side B, which will also be the same ratio as if you take the sine of angle C and divide it by side C. Notice there's two equal signs. You never use two equal signs at a time. So what this says, it says you can take any two of these fractions and you can set them equal and solve for one of the unknowns. So do you see how the law of sines sets up? Notice that each fraction is made up of an angle and the side across from it. So now that we've talked a little bit about what the formula is and how it sets up, we need to talk about how does it work. Okay, what would an example look like? Well, let's start with our first example. We're going to have a triangle where we have three angles. Remember that the capital letters are angles, and they give us that angle A is 110 degrees, and angle C is 30 degrees. We also have our sides. Lowercase letters are sides, and they give us that side C is 3. Now, why we need the law of sines, if you remember in the previous section, 8.1, that was right triangle trigonometry. We talked about chief SOHCAHTOA and the Pythagorean theorem, but those only work if you have a right triangle. So the law of sines is needed for triangles that are not necessarily right triangles. I mean, it does work for right triangles, but it also works for pretty much any triangle where you are given two angles and a non-included side, or two sides and a non-included angle. Those are the two cases where the law of sines applies. And if I could summarize that real quick, the way that I normally teach it in class, it's any time that you're given an angle and the side across from it. If you're given an angle and the side across from it, the law of sines will apply. So our goal here is going to be to solve the triangle. Remember, that means to find all of the missing pieces. So we're going to have to find these three pieces. Which is the easiest to find first? That's correct, angle B, because we know that all three angles have to add up to make 180. So if I take 180 and subtract the other two angles, that's going to give me angle B. 180 minus 110, that's 70. 70 minus 30 is 40. And real quick, with some arithmetic, we get angle B. Okay, one down, two to go. And remember, this is not a right triangle. None of the angles are 90 degrees. So we're going to have to use another tool other than SOHCAHTOA and Pythagorean theorem. And so that's where the law of sines comes in. So what we have here, this is the basic template for how you set up the law of sines to solve for an unknown. One of the fractions has to have numbers top and bottom, and the other fraction needs one variable. Now, recall that letters that match go in the same fraction, so we're going to start with sine of C over C, and then you can determine whether you want to find A or B first. Let's do it in alphabetical order, okay? We want to find little a first. So in the same fraction is going to have to be angle A. And now that I have a proportion, to solve a proportion, you cross multiply. So we're going to have a times sine of 30 equals 3 times sine of 110. We need to divide by sine of 30 to get a by itself. And then with a little button pushing, we're going to have our answer for A. All right, so here we go. With the calculator, make sure you're in the right mode. We need to be in degree mode since these angles are degrees. 3 sine of 110 over sine of 30 works out to be not a nice number. So they're going to have to specify in the instructions where to round. I'm going to round to the nearest tenth in this entire lesson, okay? Everything to the nearest tenth, 5.6 units. And so now we have A is 5.6. And now the last piece of the puzzle to find is B. And if you're thinking, oh, I have two sides, I can find the third side with Pythagorean theorem. No, you can't. This is not a right triangle. So what we're going to have to do is we're going to have to use the law of sines again. Use the law of sines. Now this is where I get to tell you it's good to recycle. The fraction that had numbers top and bottom, we're going to recycle that. Now we're looking for little b, so above that we need angle B. And once you get your proportion set up, then you cross multiply. Here we go. B sine of 30 equals 3 sine of 40. Divide by sine of 30. And now I want you to notice something. Look at how this fraction compares to the one we input a second ago. Do you notice the only difference here is the angle that we're using? So what I can do then, real easy, if I've got this calculator, is I can just scroll back and delete the 110 and insert the 40. Do you see that's pretty much the same button pushes with 40 instead of 110? And again, rounded to the nearest tenth, 3.9, rounded. And we're done. That's it for that example. Once you find all the missing pieces, you have solved the triangle. Next problem, again, we're going to have three angles, A, B, and C, and three sides, A, B, and C. And for this example, we're going to be given that angle A is 50, side A is 3, and side B is 2. Now let's scroll back up and look at our law of sines. Here I want you to notice that we're given an angle and two sides. That's this one, an angle and two sides. All right, so I do want to make a point here. Angle A is 50. I'm going to use this triangle here for reference. Angle A is 50, A is 3, and B is 2. Okay, now do you see that with this setup, this is an angle side because we have an angle and the side across from it. If you would have been given side C instead, this would then be a side angle side, which you could not use the law of sines to solve, right? You don't have an angle and the side across from it. So in the next lesson on section 8.3, we're going to cover side angle side. But I just wanted you to notice that the reason the law of sines applies here, what makes it a side angle, is the fact that you're given an angle and the side across from it. That's when the law of sines applies. And now we also have to bring in the ambiguous case, okay? This is a special case that applies when you're given a side angle setup. And you always have to consider the ambiguous case if you have a side angle. Okay, so here's what it says. It says if you are given only one angle, and that angle must be acute, and the opposite side is less than the adjacent side, then you may have two sets of answers. That's what the ambiguous case says. Notice there's two criteria that have to be met. You have to have only one angle that's acute, and the opposite side has to be less than the adjacent side. If both of those cases are met, then you have to check for maybe two sets of answers. Okay, so let's see what we've got here. Are we given only one angle? Is that angle acute? Yes. Next, is the opposite side less than the adjacent side? Okay, that means when we say the opposite side, we mean the side opposite of the angle. Is the opposite side less than the other side? No, it's not. And that means that this is not going to be the ambiguous case. But remember I said anytime you're given a side angle setup, you have to check for that. So we're going to work this as we normally would. Here we're going to use the law of sines. And remember I said that letters that match go in the same fraction. So our first fraction is going to be sine 50 over 3. The only other number I'm given is little b, which means I'm going to have to solve for big B. And now that I have my proportion set up, I can cross multiply. Here we go. 3 sine of B equals 2 sine of 50. We're solving for B, so we're going to have to divide by 3. And that's going to give us sine B is whatever that fraction is. And so if we pull up the calculator with the fraction, we're going to have 2 sine of 50 divided by 3. And again, now listen, this is an intermediate step. This is not the final answer. And so I'm going to round it to 4 decimal places to keep my final answer as accurate as possible. Intermediate steps, we're going to round to at least 4 places. So 0.5107 rounded. Next, to solve for angle B, we're going to move the sine over. That's going to turn that into inverse sine of 0.5107. And again, we're going to have to go back to the calculator. And we're going to do the inverse sine of the previous answer. Now, when you use previous answer like this, it actually uses all of those decimals, and it makes the answer as accurate as possible. Again, we're going to round to the nearest tenth, 30.7, and that's going to be degrees. Okay, that's angle B, 30.7. And that is 1 down, 2 to go. 1 down, 2 to go. The next easiest piece to calculate would be angle C. That's going to be 180 minus the other 2 angles. And if I pull up my handy dandy calculator, and I don't know if you noticed, but I like to use the calculator. I need a decimal. Let's hit the SD button. Bam, 99.3. Yeah, 99.3. I use the calculator because really, I don't trust myself. I just want to make absolutely sure that I'm right. And we've got one more piece to find. Guess how we're going to find it? That's right. We're going to use the law of sines again. We're going to use the law of sines. Hey, it's good to recycle. 50 and 3, we're going to recycle that. Now we're looking for little c, which means we need to use angle C. And now that we have our proportion, we can cross multiply. C times sine of 50 equals 3 sine 99.3 divided by sine of 50. And to the calculator. Let's see here. 3 sine 99.3 close parenthesis divided by sine 50 works out to be to the nearest tenth, 3.9 rounded, 3.9. And we're done. All three pieces are found. Let's do another example. So here we're going to start with angle C is 70, A is 3, and B is 7. So if we look at what we're given here, we're given an angle and two sides. This is a side-side angle, not a side angle side. And just real quick, the fastest way to know if you have a side angle side, which is different than a side-side angle, to have side angle side, the three letters that you're given all have to be different. So you would have to be given little a, little b, and big C, ABC. That's how you know for sure that you have a side angle side, is that all three letters that they give you numbers for are different. They have to give you A, B, and C. All right, so now let's see, since we do have side-side angle, I need to draw your attention back to the ambiguous case. Anytime you have a side-side angle, we have to check and see if the angle we're given is acute and if the opposite side is less than the adjacent side. So here our one angle is acute, check, and the opposite side, which is 3, is that less than the other side? Yes, it is. And so this does meet the criteria for the ambiguous case. Now, that doesn't mean anything different about how to start the problem, but it means once we get going, we might need to check and see if there's two sets of answers, okay? No, the way we're going to start is the way that we always do. Remember that one fraction has to have numbers top and bottom, and letters that match go in the same fraction. So we're going to have sine 70 over 3. The only other number given is little b, which means we're going to have to find angle B first. There is no other way to set this up, and then we're going to cross multiply. 3 sine of B, 7 sine of 7D. We're solving for angle B, so we have to divide by 3. And then what I'm going to do to calculate that value is bring up my calculator. Here we go. 7 sine 70 divided by 3 works out to be 2 point. Now remember, this is an intermediate step, so we need to go to 4 places. 2.1926. Okay? Oh, and math secret, if this number is bigger than 1, no triangle. Okay? Did you catch that? If this decimal number turns out to be bigger than 1, law of sines, no solution. All right. No, let's keep going though. 2.1926. Okay. Next step, if we're going to solve for angle B, we have to bring the sine to the other side, which is going to make that inverse sine of 2.1926. So then if I bring up my handy dandy calculator, we're going to do inverse sine of 2.1926. Error. Error, guess what that means? No triangle. Okay, there's no solution for angle B, and that means that we're going to actually just write no triangle. Now, what does that really mean? That means that this scenario, if you put these together, there's no other angles inside combination that's going to work for that. And I think I probably could demonstrate that visually if I think of, okay, let me think about that for a second. So what we know is that this side B is so far away from angle A, and side A is so short that no matter where he rotates to, no matter what this angle is, he's never going to be able to touch the other side. So not any setup is going to produce a triangle. This is a no solution or a no triangle. Just so you know, if you have the ambiguous case, notice it says you may have two sets of answers. Guess what? You may not. It may be no solution or no triangle, or it may be only one triangle. So it doesn't have to be two solutions. It could be no solution, one solution, or two solutions. And you're not going to know necessarily what it is until you start working the problem. Again, we're going to be given three angles, angle A, B, and C, and three sides, A, B, and C. And let's see, what are we going to be given this time? Angle B is 20 degrees. Side B is 4. And side C is 6. So this is the setup we're going to have here for the last one. Notice that we do have an angle and two sides. This is a side-side angle setup. We know for sure that it's not a side angle side setup. Remember, for it to be side angle side, all three letters would have to be different. So we would have needed to have been given angle A for it to be side angle sides. Then we would be given A, B, and C. But since we're given angle B, this is a side-side angle setup. All right, so remember, if you're given a side-side angle setup, you have to check to see if it meets the criteria for the ambiguous case. So the one angle that we're given, it has to be acute, and the opposite side must be less than the other side, the adjacent side or the other side. If both of those criteria are met, you may have two sets of answers, you may not. It could be no solution, or it could only be one set of answers. So let's check and see if this meets the criteria for the ambiguous case. The one angle we're given is acute, check. And the opposite side, which would be 4, is that less than the other side? Yes, it is. And that means that this meets the criteria for the ambiguous case. And that means that we need to check later and see if we have two sets of answers maybe. All right, so let's start with the law of signs. Setting up the law of signs, letters that match go in the same fraction. So that's going to be sine 20 over 4. The 6 is the only other number given, so it has to be used. And that means we're looking for angle C. And now that we have the proportion set up, we need to cross multiply. 4 sine of C equals 6 sine of 20. We're solving for angle C, so we need to divide by 4. And then I'm going to bring up my handy dandy calculator to calculate that. Here we go. We've got 6 sine 20 divided by 4. Oh, and this is an intermediate step, so I need to take that to 4 decimal places, 0.5130 rounded. And then to solve for angle C, we're going to bring the sign over. That's going to turn that into inverse sine of 0.513. The 0 there is optional if I want to write it. And again, to the calculator, we're going to do the inverse sine of the previous answer. Now, this needs to be rounded to the nearest tenth, 30.9. 30.9 degrees, okay? Once you find the first piece of the triangle, remember in the previous example, the very first piece that we got to came up with an error message, and that meant no triangle. So if it's going to be no solution, you're going to know that immediately at the very first piece of the puzzle. We got an answer. Okay, so what that means is it means that we need to find one complete set of angles and then check and see if there's a second set of angles. So what are we're going to call this angle C1, and then we're going to be able to find angle A1. Remember that all 3 angles have to add up to make 180. And so the angle A1 would have to be 180 minus the other 2 angles given. And so A1 would be, let me slide this over some so it's not in the way of my calculator. 180 minus 20 minus 30.9 equals SD 129.1. 129.1 degrees. And now I want you to notice what we have. At this point, we now have angle B, angle A, and angle C. We now have one complete set of angles. Now we need to see if there is another set of answers, another set of angles. If there's not, we know there's at least going to be one set of answers. So you may be wondering, what do I do to check for the second set of answers? How does that work? Well, are you listening? What I'm about to say is important. You always take the first angle you found and subtract it from 180. If there is a second angle C, it's going to be 180 minus the first angle C. Which angle do you subtract from 180? You always subtract the first angle you found from 180. And that's going to give us angle C2. On the calculator, 180 minus 30.9 SD, so 149.1. If there is a second angle C, that's what it's going to be. And now we have to look for the second angle A. Okay, now you don't subtract it from 180, okay? Remember, this is the last angle to complete the triangle. We already know angle B is 20. That's a given. And now we know angle C is this angle. So if there is an A2, it's going to have to complete the 180. It's going to be 180 minus the other 2 angles. So it's going to be 180 minus angle B minus the new angle C to get the new angle A. And again, if I scoot that over so it's not in the way of my calculator, Oh, look at that, it's positive. Now, if this number would have come up negative, then we would only have one set of answers, because you can't have a negative angle, and that's how you know whether you're going to have one set of answers or two set of answers. If this very last angle comes up positive, which it did, that means that we are going to have two sets of answers, okay? So now if we go back to what we were looking for here, we now have angle A1 and A2. We have angle C1 and C2. Guess what about side A? Yeah, there's going to be a side A1 and a side A2. And guess how we're going to find both of those? Yeah, with the law of sines. So we're going to come over here. We're going to say sine equals sine. That's the template. Oh, don't forget, it's good to recycle. So the 20 and 4, we're going to recycle that. We're looking for little a1, which means we need to use angle A1, 129.1. And now that we have our proportion set up, we need to cross multiply. So A1 times sine 20 is going to equal 4 times sine of 129.1 divided by sine of 20. And then if I could pull that over here, we're about to have little a1, the first side A. That is going to be 4 sine of 129.1 divided by sine of 20. And we need to round that to the nearest tenth. 9.1 rounded. 9.1 rounded. Okay, so now how do I find little a2? I would like to make you aware of a shortcut here. This set of button pushes right here, we're going to recycle that. Remember, this was angle A1. Now all we have to do is substitute in its place angle A2. And so what was angle A2? That was 10.9. Okay, so we're going to do the same button pushes. Okay, but instead of 129.1, we're going to use angle A2. Everything else exactly the same. 2.2 rounded. 2.2 rounded. There's A2. All right, so now let's make a list of everything that we found, because I want to demonstrate what I want to see on the test, okay? A1 and A2. That was 129.1 and 10.9. And then C1 and C2, 30.9, 149.1, and then A1 and A2. And that was 9.1 and 2.2. 9.1, 2.2. And then put a nice red box around that. And there is the solution. And this ambiguous case problem did actually have two sets of answers. And now you see how to attack that, hopefully, when there are two sets of answers. Now, the only other thing that I haven't demonstrated is an application problem, like a word problem. But if you understand how to recognize that it is law of sines, remember, in order to be law of sines, it has to be either an angle side or a side angle. If you understand that and know how to set up your proportion, then an application problem should be even easier than these problems, because you probably only have to find one piece of information rather than a whole triangle. And that's going to do it for this lesson, okay? So if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.